The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Converting compound names into formulas. Now, firstly, what does the chemical formula tell us? Let's just take a look at the definition quick, and then we'll move forward. The chemical formula or formula of an ionic compound denotes the constituent elements and the ratio in which they combine. Now, converting compound names into formulas is also fairly simple. We can just use this three-step process here to the right. And let's go ahead and take a look at that now. The guide to writing formula from ionic compound name. Step 1, we identify the ions, that's the cations and anions. Step 2, we identify, we're going to balance the charges. And in step 3, we write the formula, cations first, and use subscripts from charge balance. And let's go ahead and do an example. We'll start here with iron 3 sulfide. And in step 1, let's first go ahead and identify identify the ions. Let's do that on the next slide. Our iron is going to be our cation, sulfur is going to be our anion, and the iron is going to have, in the parentheses, we're being told it's going to have a +3 charge. The sulfide anion is from main group 6, and we know that main group 6 has main group 6 anions have a -2 charge. Recall this slide just a few moments ago when we had taken a look, as you see here, right? They're going to have a -2 charge. Coming back here now, so we have the following cation, anion with the following charges. Now let's get back to our slide here. Knowing that bit of information, we can just go ahead and take some of this info out. Now, before we can write the formula, we need to balance the positive and the negative charges of the cation and anion, right? So we're going to need to balance those charges. Let's go ahead and do that next. And in order to obtain a sum of 0 for the sum of the charges, right? If we go ahead and we write in our formula, we see that we're going to need 2 irons, right? And we're going to need 3 sulfurs as such, and in doing so, the sum of our charges is balanced. Now we're ready for step 3, and we're ready to write formulas. And when we write the formulas, we have to be careful to make sure that we write the cations first. Now, if we take a look here, we see that we have the cation is going to be our iron cation, right? And we have 2. And to demonstrate that we have 2 irons and 3 sulfurs present, we just write them as subscripts for the formula for iron 3 sulfide. Thus, our answer is as follows. Now, one thing that I wanted to point out here was whenever you're balancing the ions and you have charges of +3 and -2. As we do here, right, +3 and -2, or say you had, or say it was +2 and -3, then if we take a look here at figure 1.2, the charge on one ion becomes the subscript on the other, and the charge on the other ion will become the subscript on the other as well. Now, let's go ahead and do a few examples on the next slide. Okay, taking a look here, we are now going to example converting names into formulas. Provide the formulas for the following compounds. Table 1.4b, we're given the systematic name. We just need to complete the table by providing the compounds, right? Now, at this point, I'm going to ask you to pause the video, and again, I encourage you to try this yourself. However, if you still require a little bit of practice, I'll go ahead and I'll provide an explanation now for copper 2 oxide. After that point, I'll subsequently go ahead and I'll unveil unveil the answers to the rest of the table. Let's go ahead and take a look at copper 2 oxide next here. Now, for copper 2 oxide, we'll begin by identifying our cation and anion. So the copper is going to be our is going to be our cation, the oxygen is going to be our anion. Now the charge on the copper, as we see, is a transition metal, so it's most likely going to have a more than one charge, right? We see here that the copper cation has a charge of +2, and knowing that the oxide anion comes from the main group, is a main group 6 anion, it's going to have a -2 charge, right? Thus, if we go ahead and we unveil this, taking a look here, one thing that we want to notice here is now that we have the following, our cation and our anion, we found our cation and anion, and we know the charges, right? We know the charges. Now, if we take a look, the charges are already balanced, right? +2 and -2. Because the charges are already balanced, the ratio in which the copper and the oxygen appear is simply just going to be 1:1. Knowing that bit of information, we end up with the following formula here for copper to oxide. Let's go ahead and see if that's correct. Coming back here, we end up with, yes, it is. Now, at this point, I'm going to ask you once again, encourage you to pause the video. Otherwise, I'm going to go ahead and unveil the answers for the rest of the table. Let's do that next. There we are. Hopefully you got it correct. Let's go ahead now and move ahead to our next slide.